So, yesterday we looked at identifying bot and MEV arbitrage transactions and swaps in Uniswap. And today we're going to take it a step further and try to figure out what contracts or addresses are calling the pair, right? So this means going more than just one layer deep in the call traces. I'm going to let Jackie explain the logic and run through the query.
Thank you, Andrew. So to get the frequency and the volume for the swaps, we already know the drill. We just need to look at the pair call swap table, and then we grab the transaction hash for frequency with the count function. Then we grab the amount 0 and amount 1 per usual to calculate the USD volume later. And we know we need the prices, the USD table to adjust for the USD price. Okay, so now the hard part, identifying the sources, identifying if the originator of the swap is actually a contract or a externally owned account or the wallets. Remember in day 3, we looked at the router problem, right? So we saw that a lot of times the Uniswap router actually routes the swapping cost for you to find what pairs to call to conduct the swap. If we look at only one level above to see who called the swap, a lot of time that's going to be the routers, right? So if we want to truly analyze the actual originator of the swap cost, we have to look further. We not only have to look at the caller of the swap, we have to look at who actually called the caller that called the swap. We need to do 2 joins on the traces. First time join to identify the caller of the call swap. Second time to identify the caller of the swap. Once we identify the originating swaps, we're going to find if the address exists in the creation traces table. If not, then it's an externally owned account. If it is, then it's a contract. And then we can use the contracts label to identify the address further. And then we'll be able to conduct our analysis on the frequency and volume of the sources. All right, let's get into it. Let's start with setting up our CTE. So with swaps as, and per usual, we are going to select from the swap call table. So going to find the name of the table, Uniswap V2 pair, search for swap. Okay, so from this, aliasing as S. Let's just set up the time already because we know that we need that. So date truncating by minute because we know we need the minute data to join to find the USD price later on. So we will do a call block time, this time. Okay, so next we know that we need to perform joins on the traces, right? Because we need to find the caller of the swap. To find the caller of the swap directly, we can join by the transaction hash as well as the call trace address. So each internal calls in a particular transaction would have a unique trace address. And then to find that particular internal transaction, we can use the trace address to join and then find that. And then once we have that, we would be able to go one layer above to find what we need to find. So trace address is a pretty useful field when we are playing with traces table. Okay, so before we even go to joining on the traces, let's just think through the logic that we need to do this self-joining on the traces, essentially joining on the traces table twice to find the caller of the swap, right? So I'm gonna start a commenting block. You can do a block commenting by doing this on the screen like you can see. So here we're gonna just find the caller of the swap, right? Okay, step 1, let's just set this up. How would this look? So it would have 2 layers of from 2, right? So this is more the top layer, and then this is the lower layer, which is actually closer to the swap. So here, this 2 would be the actual pair contract address. So this would be our USDC and wrapped ETH contract address. So pair contract for swapping, right? For swapping. And then, so this from would be the address that actually called the swap. So the direct caller of the swap, right? So this is the caller. So if we go on one layer above, ideally what we would want to grab is the 2 would be the from. So these would both be the caller, the direct caller of the swap. And then this from would actually be the actual caller of the color that we're interested in getting, right? So this would be the color of the color. Okay, so that's what we want. And then, so in terms of joining this, we're gonna just call it the first trace address table that we're joining, because this is the trace table that we're gonna match directly with the swap calls trace address. So we're gonna identify it that way. So let's just put it here. So essentially what this would be the traces one dot trace trace address would equal to the swap call trace address. So that's how you can identify this particular record. And on top of that, if you want to identify this particular record, what we need to do is, so this would be the second traces, right? Second traces we're trying to join. So essentially what we're saying is traces one dot from is equal to traces two dot two, right? Because we're trying to match this two with this from. Okay, so that's one of the things we need to do. Then there's one more thing we need to do, because structurally we can see that this row should always come before this row. How do we identify that? So when we look at the call trace address, right, it could look like 0, 0, 5, 1, right? So this is what it could look like. So what comes after it would look like either this, or it could look like, you know, with one more. So whatever comes at later would always have either the same length or like a longer length, right? So that's what we also need to do. So make sure the array length of this particular record is always equal or smaller than the array length of this call. So we could do that. So let's say, so it would be like the cardinality of trace two trace address. I guess instead of saying of, just make it a function. So this is always going to be less than or equal to the cardinality of trace one, right? Based on this like structure visualization we're looking here. Okay, so I think we're ready to perform this join. So let's get into it. So we are going to do a left join on Ethereum dot traces t, which we're going to call t1, and then we are going to join on t1 dot transaction hash, right? Because we want to make sure it's actually the same transaction, equals to us call transaction hash, right? Because joining on the same transaction. And then what else? Let's join also on the time y, just to make sure we're querying more optimally and the query is cycling through like less data. So let's get the time match going, and then let's get the trace address going, right? So we know that the trace address in this trace should exactly equal to the call trace address in our swap call table. Right, so basically here we are able to join the first trace, and then let's do the second trace join. Okay, so here what are we doing? We want to make sure that these two, because we want to join the traces 1 and traces 2 together, right? We're performing a self join, so we want to do trace hash is equal to t2 dot transaction hash. Okay, what else? Again, we're gonna just join on the time to make it cycle through less data. Block time. Okay, what else? We are going to do this part of the logic, right? So we're gonna do and t1 dot from. We need to, this is like a special reserved keyword, so we need to put in double quotation is equal to t2 dot 2. Okay, and what else? Sometimes there would be cases where, you know, t1's from and t2's from are the same, so we need to also filter that out. t1 dot from is not equal to t2 dot from. And then we need to then go to our last condition, right, on the cardinality. Sometimes cardinality could be 0, right, if an array could be null. Sometimes cardinality could be null, so if the array has nothing, then it will be null, and we don't want to have error, so we're going to just do a coalesce here. In case it's null, then we're going to put 0, but in case it's not null, then we're going to get the cardinality of t1's trace, I guess we said t2 dot trace address is always going to be smaller or equal to another coalesce function, right? If it's null, then we put 0. Otherwise, we're going to get the cardinality of t1 dot trace address. Okay, cool. So we are good on the self join. We're gonna double check if there's an error after we set up the rest of the query. Okay, now we need to consider some of the filtering condition, as well as make sure we grab all the columns that we need. So let's start the where clause for the filter condition. So here I'm just gonna do a 1 equals to 1 just to make our commenting a little easier later. 1 is always gonna be equal to 1. So whenever you want to do more and, right, you can always easily comment out the and condition. So that's what we're doing here. Okay, so first of all, we're gonna get like a lot of data. So we want to just filter for the time in the past, like let's say 8 months. So call block time is greater than or equal to now. Actually, to start with, let's just like filter for, honestly, we can like filter for the past 1 day and start making sure it's correct and then go more. And we also want to make sure like we are looking at the USDC wrapped ETH pair, right? So we want to make sure the contract address is what we care about. So here we're going to introduce a parameter. As usual, we are going to find the default address, USDC wrapped ETH. USDC ETH by default. Okay, and then we also want to make sure that the traces are successful. The calls are successful calls, right? Because sometimes you initiate a transaction and it's not necessarily successful. So we're gonna make sure that it's success and t2.success. They are Boolean, so you don't have to say anything. If it's true, that it's gonna be true. And we also want to filter out static calls on these traces. So t1.call type is equal to call, because when it's a call type, it actually changes the state. Otherwise, if it's a static call, it doesn't do anything. So we want to make sure we filter for the right type of call type. Okay, cool. So these are our filtering condition. So what do we need? We need this particular from, right? That is our ultimate goal. So we're gonna do t2.from. This is our raw source. So this is the caller of the swap, right? The double caller. We're gonna just call it double caller. And then t1.from is the direct caller, so the direct source. All right, there's actually something more that we need to do. Here, this is like our logic, right? We want to get the caller of the caller, so from of the from. But sometimes there could be rows where, like in the same transaction, there would be like this, right? So there would be multiple rows that would satisfy our requirement even if we filtered for, hey, let's look for cardinality of this row less than this row, because anything comes before technically would also satisfy our requirement of this, right? The traces 2 is less than the traces 1's cardinality or array length. So we are going to apply a window function row number to make sure that we are indeed looking at this closest one to this run. So we're indeed getting this from instead of any other from. Okay, so we're going to do row number. So we're just trying our best to find the originator of the call. It might not be 100% bulletproof, but this is our approach. Definitely let us know. any other approach that you have. So we're partitioning by the T2.transaction hash because we're looking at within each particular transaction what is happening. So we're ordering by the cardinality of the trace address, right? And then we're ordering it in a descending order. And then we're naming it as row num. Okay, so essentially what this does is that the longest trace address array, so the one closest to this row, would have the row number being 1, and then we are interested in grabbing this particular row that's closest to this row instead of any other. So that's our row num that we have set up. This is the hard part, right? This is done. So the easy part, we already know that we want the call transaction hash for frequency, and also as an example later, as transaction hash. Okay, so this is for, and then we need to grab the same amount 0, amount 1 as before. So we like can calculate the volume, right? So for volume, and then we are just going to do our usual case statement. So case when we're gonna cast the amount. So when amount 0 out as double is equal to 0, then we're going to basically use amount 1 as the raw amount. So we're gonna just cast it so we can use it more easily later. Amount 1 out. Honestly, I'm just gonna amount 1 out. I'm gonna just use the copy pasting here. So cast amount 0 out as 0, then we're gonna take that. Else we're gonna take, oh, forgot to as double. So else we are going to take amount 0 out as double, and then we're gonna end the case statement as the raw amount. Okay, what else? We want to grab the token address, right, for these token so that we can adjust for USD later. So in order to do that, we would need to perform another join with the pair creation, right? We already know that from before. So go into factory and then go into event, pair created, PC dot. This would be the pair address is equal to s dot contract address, I believe. Yes. Contract address. Okay, so now we got the pair. So case when I'm gonna copy this part down and then change this to B, the token address. Okay, so here if amount 0 is 0, then we know we want token 1 as the address, otherwise it would be token 0. Awesome. Okay, cool. So that should be all for our first part of the query. Let's give it a try to, test out if this indeed worked. So let's do a limit 100 and see. Okay, there's an error. PC left join on, forgot to. All right, let's take a look at an example transaction. So let's take this one where the row number is 2 to C. So copy the transaction hash 408, and then we're actually gonna just use the Ethereum traces table on Dune, do the investigation. So gonna paste the transaction hash over and take a quick look. We have the results for this one. So now we have the results, right? We want to look at the fragment 2, and here we're gonna just copy paste the swap pair address to filter it down so like we can search for it even more easy. So let's just search from the UI directly. Okay, we can see that this is the call that called the swap directly. So this would be the direct caller of the swap, which is 7A25, right? Which let's filter for this particular transaction hash so we don't get super confused, which matches up our expectation. And then let's again filter for the 7A15, no, 7A25. And then we can see, okay, indeed, this is the color of the color, right? So 8BC. And then here we can see 8BC matches up our expectation. And here, all of the raw source is the same, but sometimes it could be different. But we know that we want the closest internal transaction that called the color of the swap. So it would be like row number equals to 1. Yeah, so sanity check, all works out. We are good to go here. Let's delete the limit to 100 and let's put this back. Let's also put that back. Okay, we are ready to continue. This is the hardest part. If you're here, you're already 80% there. Let's filter for row number equals to 1, right? So we're gonna call this interswaps for intermediary step. And then we're gonna do select star from swaps, basically where row number equals to 1. So we're basically taking the closest color of the color. So like from, right? Next step, we already know how to do this. We're gonna just like label the addresses. So we're gonna call this labeled swaps. Okay, so we're doing select from interswaps, aliasing this again as us. Some obvious things we would need. We definitely need the time, and then definitely still want the transaction hash, and then definitely want to keep the raw amount, and then the token address. Definitely need these, but now we would like to label our raw source, right? That's essentially what we would like to do. To do that, we can do two things. One, we can join on the Ethereum creation traces. So let's do that. Creation traces. We're gonna call this C on. So the raw source that we care about, the address, is going to be equal to the creation address. We already know this. This is checking if it's a contract or an EOA, checking if it's a contract or EOA, right? If it's an EOA, then it would not exist here. If it's a contract, then it would exist here. And then another thing is, if it is a contract, we can use labels that contract to further using labels contract to label the contract address, right? So we can do a left join on that, but so we can directly do labels the contracts, okay, on the raw source equals to the, we're gonna alias this as L, L address, right? And then also on L making sure L address, not L address, making sure the blockchain for L is Ethereum. So contains L dot blockchain is Ethereum. Why are we using it contains instead of equal? Because here for the labels contract table, we know that the blockchain column is of a array type. So yes, so now we've got the labels table. So we now can do the transformation part. So what are we doing? We're basically saying when the address is null, so when the raw source cannot be detected in the creation traces table, then we're gonna label it wallet or externally owned account, right? Else it is a contract, and then we can try to use the label name, label table, so we can see if there is a name associated with it. If not, we're gonna just simply label this as either contract, and then we're gonna end it as our labeled source. Okay, let's do some sanity check here again to just see. Okay, it should be, let's see, a bunch of wallet and externally owned account. Okay, so let's take a transaction and check if it is indeed a wallet. So let's go to Etherscan and see. Okay, let's go there. It's really weird. Normally there is an internal transactions table, but let's just check from our own traces table. Normally I would go to Etherscan to like see what's going on, but today's kind of weird. First we need to grab our, okay, so first let's make sure we're only looking at this transaction, and then let's grab our call swap. Let's grab our USDC wrapped ETH address, and then so we can see 68B3 initiated this, and who caused 68B3? That is not 68B3, right? Because we want to see it is BFF2, and BFF2 is an address. Okay, wonderful. So sanity check passes. We're gonna delete this one more time. Great. Labeled swaps. Next step, we labeled it. We are going to adjust for the USD amount. Gonna call it enriched pairs as, okay, so we're selecting the time because we always need the time, right? And then the source that we just adjusted, and then transaction hash. And we already know this, so we are getting the raw amount. So before that, let's just set it up. So from label swaps. Okay, so, and let's alias this, maybe? No, I think that's okay. From raw amount, okay, divided by 10 to the whatever decimal. So in order to get the decimal, we need to join on the prices. So let's do that. Prices.usd. Wonderful. We're joining on the minute equals to the time, and then also we want to make sure the token address matches, right? So the prices.contract address is the token address. And also we want to only look at the Ethereum chain data for the price. And then one more thing, we want to filter for the time. And then right now, since we're filtering for 1 day, let's just keep it consistent. 1 day. Let's actually change this into inner join to filter out any token that does not exist in prices.usd table, so we cannot adjust for the price. So then we can do dot decimals, basically. And then after that, we can do the price, time the price as the amount USD. Okay, we are good to go here. So let's write the last part of the query. Final part of the query is where we're gonna start aggregating up by the weekly. So let's set up, select from this enriched pairs. Beautiful. And then we're gonna truncate it this time to week. So time as time. And then we're gonna just use the source, right? And then we are going to aggregate up the count of the transaction hash, right? As example hash, and then we're going to sum up the USD or amount USD, yeah, amount USD as the sum amount USD. Actually, let's do something else as well. So we're gonna call this detailed source, because in terms of like readability for the graphs, we want to just simplify things a little bit. So we're gonna only identify a few prominent contracts. So case when, if the source is just wallet or EOA, then we're gonna keep the source, but else, so when source looks like some sort of Uniswap, right? Like when the label, the name of the contract is some sort of Uniswap, then we're gonna call it Uniswap regardless of what kind of Uniswap it is. So when source are like 0x, then we're going to just call it 0x. Similarly, another source that, let's just take a look at could be 1 inch, then it would be 1 inch. And then, so when source is like Paraswap, then we're gonna say Paraswap. Okay, let's stop there. And then else we're gonna call it other contracts. Then we're gonna end the case statement. So this will be like our source. Otherwise we can look at the detailed source. So that is our pair. And then let's apply one more aggregate function to get the arbitrary transaction hash to be used as an example later. Sorry, this is the frequency. And that's the example hash. All right, cool. So let's just get the group by going. Group by 1, 2, 3. Okay, so let's see what's gonna happen. Okay, so forgot to put the as on, so let's do that. But also we don't need this part. Okay, beautiful. Let's just create a visualization to double check this part. Looking at the sum group by the source. Okay, it's something in terms of wallet. This looks pretty okay to me. Obviously, we won't have 1 day data. That's why it's like that. Let's get going with the last part. So, select. We want the time for sure. We want the frequency. We want the source. Okay, let's do it like this. Doesn't really matter, but okay, so some amount USD. And then we're gonna do the same thing that we did before to make the example hash clickable. Honestly, I'm just going to copy paste from the previous days because it's a lot to just rewrite it. Going to literally copy paste this, and then we're gonna copy paste this. Beautiful. Okay, so I think it's literally called example hash. Okay, cool. And then we're going to copy paste this from final as well. Yeah, let's get this going. Oh, let's stop this. Let me find the day. 1 day. Yep. Okay, so let's replace that with the past 8 months so we see like a bit more pattern. Okay, let's get this going. What's wrong here? Let's do this 8 month. Okay, looks like we have some answers. Let's take a look at some of them. Let's see, so this one, internal transactions. Wonderful. Okay, so it looks like Etherscan is back. Okay, so B4E1 is here, and then 7 something is basically called by this person. So this is a contract. This is an other contract. This is what this is what we are expecting. Okay, so let's get the bar chart going. Source. Yep, that is what I want. So we're gonna enable stacking. So this would be our USD, right? This is our USD volume, Okay, and then we're gonna create another one for frequency. Source, nope, frequency, group by source, enable stacking, and then we're gonna call this frequency. We can already see predominantly it's just wallet or externally owned account here. Most of the caller of the Uniswap wrapped ETH call is actually from externally owned account or like our wallet, which makes sense. Okay, so that is the answer for day 5. This is not a bulletproof situation to see the actual originator of the call, but we're trying to get it to the true source of the actual swap call.
Thank you, Jackie. Great walkthrough as per usual. For the bonus points, try and see if you can categorize the sources even further, right? So you'll see a bunch of aggregator contracts, see if you can categorize things into aggregator or multi-sig, even like MEV, like adding on the MEV labels. So you should be able to get even more high fidelity categories. For tomorrow, we're going to have the ultimate query for the usage section. We're going to try and take all the variables that we've already created in the last week and put them into one query across all pairs containing the USDC token. So that we should be able to see a cluster of different USDC pairs and almost be able to rate them based on their usage value.